Have you ever noticed changes in temperature? Where one day it's breezy, then it gets scorching hot later afternoon? Or when your heart rate increases after such vigorous exercise? Well, what we have observed here are changes in data over time. There are a lot of other situations similar to this that are relevant to further discussions. We can necessarily monitor these changes through data presentations, especially in these present times. Good day everyone! This is Group 4's discussion about a type of graph called the broken line graph, which is a type of line graph. Just to share a little history background of the broken line graph, a Scottish engineer and political economist named William Playfair was the first creator of the bar charts, pie charts, and of course the line charts that we know of today. He used these charts thoroughly in his commercial and political atlas book and made it very successful and popular, making him the father of statistical graphics. We owe William Playfair so much that understanding the patterns and trends and analysis of increasing amounts or changes in data are now made possible. So, what exactly is a broken line graph?
Before starting with the topic broken line graph, let's start by explaining a line graph. A line graph is a set of data values that are connected by lines. It is useful for graphing data from many different contexts. And lastly, they have a horizontal x-axis and a vertical y-axis. Each axis represents a different data type. The x-axis typically represents the independent axis because its values are not dependent on anything measured, and while y-axis is considered a dependent axis because its values depend on the x-axis values. So, the term broken line refers to connecting data points with line segments and different slopes. The line on this type of graph is more disjointed and broken. Subsequently, the lines lack consistent slopes and can have a positive and negative slopes. For the definition of terms, we have here x-axis, the horizontal axis representing the independent axis, y-axis, the vertical axis representing the dependent axis. Data points, individual points on the graph representing specific values. Line segments, straight lines connecting consecutive data points. Slope refers to the measure of steepness or incline of the line segments connecting data points. Now I've covered the definition of the broken line graph, I'll now pass the stage to the next presenter who will explain the steps and procedures of the topic.
How do you make a broken line graph? So now, I'll be giving you 5 easy steps in making one. I'll be providing example so that you can better understand the process. So the first step would be identifying the variables. These variables are the content of the graph, such as the x and y axis. The x-axis being the opening hours of the clinic, while the y-axis being the number of capsules being used. The next step would be determining the variable range. As what you can see in the table, you can see that the lowest variable would be the 0, while the highest variable would be 13. Now, you're able to identify the variable range, which would be 0 to 13. The third step would be determining the scale of the graph. Since the highest variable would be 13, we're going to use 7 units of 2 pieces for the scale of the y-axis, or the vertical axis. The fourth step would be labeling the graph and the axis. The best title for the graph would be Number of Used Capsules at Clinic on March 8, while the x-axis, would be the opening hours, while the y-axis would be the capsules per pieces. The final step would be plotting and connecting the data points. Start plotting the data points from 8 a.m. going to 3 p.m. Then after that, you're going to connect it onwards. And that's all for the steps and procedures in making a broken line graph. Now let's proceed to the sample problems.
So the first question is, a nurse is monitoring a patient's blood oxygen saturation levels during a 12-hour night shift.
Due to intermittent issues with the pulse oximeter, some data points are missing. The recorded values and time intervals are as follows. So the following graph represents the percentage of patients' oxygen saturation during a 12-hour night shift. So while using the broken line graph, answer the following questions. So first, at what time did the patient's oxygen saturation level decrease?
The patient's SpO2 level decreased twice. First, it decreased from 98% at 0 hour to 94% at 2 hours. Another decrease of SpO2 is from 96% at 6 hours to 92% at 10 hours. Therefore, the patient's SpO2 level decreased during 2 hours and 10 hours.
Second is estimate the percentage of patients' oxygen saturation level for the missing time.
The missing time in this graph includes the 4th hour and the 8th hour, since there was an intermittent issue with the pulse oximeter. In order to estimate the percentage of the missing time, we will find the mean of the total values during the time when the pulse oximeter is functioning well. So n is equal to total percentage value over number of hours, where n represents the estimated missing time and the number of hours are those hours when the pulse oximeter is functioning well. So n is equal to 98 plus 94 plus 96 plus 92 plus 97 divided by 5 is equal to 477 divided by 5, which gives us an answer of 95.4 or 95%. Therefore, the estimated percentage of the SpO2 for the missing time is 95%.
And lastly, what was the highest recorded of the patient's oxygen saturation level during the night shift?
During the 12-hour night shift, the highest recorded SpO2 level is during the 0 hour, which shows 98% of SpO2 level.
For the second problem, Sam decides to spend some time with his friend Aaron. He hops on his bike and starts off to Aaron's house, but on his way, he gets a flat tire and must walk the remaining distance. Once he arrives at Aaron's house, they repair the flat tire, play some poker, and then Sam returns home. On his way home, Sam decides to stop at the mall to buy a book on how to play poker. The following graph represents Sam's adventure. For the first question, how far is it from Sam's house to Aaron's house? Second, how far is it from Aaron's house to the mall? Third, at what time did Sam have a flat tire? Fourth, how long did Sam stay at Aaron's house? And for the last question, at what speed did Sam travel from Aaron's house to the mall and then from the mall to home?
For the first question, how far is it from Sam's house to Aaron's house? It is 25 kilometers from Sam's house to Aaron's house. The graph gives the distance of Sam from his home at different times. To find the distance from Sam's house to Aaron's house, we need to find the value of the y-coordinate when the x-coordinate is 11 a.m. The y-coordinate when the x-coordinate is 11 a.m. is 25 kilometers. So the distance from Sam's house to Aaron's house is 25 kilometers. For the second question, how far is it from Aaron's house to the mall? It is 15 kilometers from Aaron's house to the mall. To find the solution or to find the distance from Aaron's house to the mall, we need to find the distance between the y-coordinates of the points where the graph crosses the vertical line x is equals to 12:30 p.m. and the vertical line x equals 1 p.m. The y-coordinate where the graph crosses the vertical line x is equals to 12:30 is 10 kilometers. The y-coordinate where the graph crosses the vertical line, which is the 1 p.m., is 5 kilometers. So the distance from Aaron's house to the mall is 10 kilometers plus 5 kilometers equals to 15 kilometers. For the third question, at what time did Sam have a flat tire? Sam had a flat tire at 10 a.m. The graph shows that Sam was biking from 9 a.m. to 10 a.m. At 10 a.m., the line representing the distance from home stops increasing, which means that Sam stopped biking. The line then starts increasing again at 11 a.m., which means that Sam started walking. Therefore, Sam had a flat tire at 10 a.m. For the fourth question, how long did Sam stay at Aaron's house? Sam stayed at Aaron's house for 1 hour. Sam arrives at Aaron's house at 10 a.m. and then leaves at 11 a.m. So he stays at Aaron's house for 1 hour. For the fifth question, at what speed did Sam travel from Aaron's house to the mall and then from the mall to home? Sam traveled at the speed of 30 km per hour from Aaron's house to the mall and then at the speed of 40 km per hour from the mall to home. So for the reason is that we are using the formula of the speed equals distance over time. So Sam travels 15 kilometer, which represent the distance, and then 30 minutes or 0.5 hour for time from Aaron's house to the mall, which is the speed is 30 kilometer per hour. He then travels 20 kilometer in 0.5 hours from the mall to home, which is a speed of 40 kilometer per hour. So the interpretations of this problem is that the chart depicts the time and distance covered by Sam for a day. It demonstrates that he began his trip at 9 a.m. and briefly halted at the 25-kilometer mark around 10 a.m. He continued on and paused once more at the 30-kilometer milestone, recommencing his journey at roughly 11:45 a.m. He then took a brief break at approximately 12:20 before finally arriving back home at around 12:30 p.m.
So the third question is, a hospital is tracking the number of patients admitted to its intensive care unit over the course of a year. The hospital experienced a shortage of ICU beds during the months of January through March due to staffing issues, resulting in incomplete data for those months. The following broken line graph represents number of ICU admissions per month for the rest of the year. Using the broken line graph provided, answer the following questions. First, what was the highest number of ICU admissions in a single month?
Based on the data provided, it can be observed that September had the highest number of admissions to the intensive care unit, with a total number of 90 admissions. This indicates that September experienced the greatest influx of patients requiring intensive medical care compared to other months.
Second, during which month did the hospital experience the lowest number of ICU admissions?
Based on the information provided, it can be inferred that June had the fewest admissions to the intensive care unit. With a total of 45 admissions, this suggests that June experienced the least number of patients requiring intensive medical care compared to other months.
Third, estimate the number of ICU admissions for the missing months, which is from January to March.
January to March is missing. We can estimate the values based on trends observed in the other months. Let's calculate the average number of ICU admissions for the available months, April to December. So 50 plus 55 plus 45 plus 60 plus 65 plus 90 plus 85 plus 80 plus 70 equals 610 divided by 9 equals 67.78. We'll round this to 68 admissions per month as our estimate. Since there are 3 missing months, the total estimated admissions for those months would be 68 times 3 equals 204 admissions. We can distribute this evenly across the missing months, so each missing month would approximately be 204 divided by 3 equals 68 admissions. So in summary, the highest number of ICU admissions occurred in September will be 90 admissions. The lowest number of ICU admission occurred in June will be 45 admissions. The estimated number of ICU admissions for the missing months, January to March, is approximately 68 admissions per month.
After the discussion and analyzing the broken line graph, we can state the following conclusion and generalization. First, a broken line graph is a graphical representation that uses line segments to connect data points. It is particularly useful when there are discontinuities or gaps in the data. By visually connecting the points with line segments, a broken line graph allows for a better understanding of the overall trend or pattern in the data. Second, broken line graphs are commonly used to display data that changes over time or across different categories. They are especially helpful in illustrating datasets with irregular or non-continuous values. Third, broken line graphs provide a clear visualization of the relationship between variables, making it easier to identify trends, compare data points, and make predictions. Additionally, they allow for the inclusion of multiple data series on a single graph, facilitating comparison and highlighting differences. Broken line graphs are a valuable tool for data visualization, particularly when dealing with datasets that have gaps or discontinuities. Overall, broken line graphs are a versatile tool for data analysis and communication, enabling effective representation of complex information in a concise and visually appealing manner. They provide a clear, concise way to represent trends and patterns in the data, making them a useful tool for data analysis and communication.